Venkat Vanaparthi. Check your audio settings. And hello students, please try to mute yourself from your side as well, okay? First 1 hour, I'll try to explain, and after that, last half an hour, I'll try to clarify all your doubts, okay? So here you can see, these are the topics which we are going to discuss for today. So by the end of today's class, you will be good at all these 5 options. So first of all, you need to know, Siddesh. Okay. So let us understand what are the main folders available in OData ABAP service project. So you can see I'm going to SEGW. I'm going to SEGW, that is a T code. Under SEGW, you can see we can develop our OData ABAP services. We can develop our OData ABAP services in SEGW transaction code. And first of all, let me create one simple project. So there is a create symbol here. When you click on create symbol, it will allow you to create OData service project. So I'm giving some project name and some description. And in real time, always save it in a package. In real time, always save it in a package. Don't forget that. So now you can see all these folders are created here. There are 4 main folders. You can see those things. Data model, service implementation, runtime artifacts, and service maintenance. So let me just give a note here. The main folders in OData ABAP service project. The first one is, I can say, data model. And second one, you can see something like service implementation. Service implementation. And third one, runtime artifacts. Runtime artifacts is another folder, and the fourth one is service maintenance. So these are the 4 main folders that will be created under every So, and you can see here, I just want to create. I want to create one entity type and entity set. I want to create entity type, entity set with some fields. So how can we do that? So you can see here, if you right click data model, you'll get one option like import DDIC structure. You can right click data model and import DDIC structure. So by using that option, you can create entity type as well as entity set. That is, for example, I'm using EMP as entity type. I'm using EMP as entity type, and I want to take the fields from our database table, for example, Z user info. I want to take a database table structure that is Z user info. So that is the table available already in S11. You can use VBAK or you can use VBAP or whatever. But as of now, I'm just using Z user info database table structure. And I need to select this checkbox to create an entity set. We need to create an entity set. So to do that, you have to select a checkbox. So that means in this screen, two things are happening. In this screen, two things are happening. One is entity type is getting created. Entity type is getting created here as EMP. And we are taking this entity type. Why we are creating entity type? Just to get the fields. We are creating entity type just to get the fields. So I'm using DDIC structure, something like equal to Z user info. That's a DDIC structure from S11 to get the fields from that structure or table. And in the third case, you can see we are creating an entity set. We are creating an entity set here. So that is nothing but set becomes EMP set. Automatically, entity set becomes EMP set here. So please notice that entity type we are creating, entity set we are creating by taking DDIC structure. So this is what we generally do when we start our OData development. Without entity type, without entity set, we can't develop anything in OData service. These are essential. So let me just write a simple note. So you can go to GWT code and create a Z 9 p.m. something like OData project with the default settings or with the description you can provide and save it in package. You can save it in package. Then once, let me check. So we are creating a project with some basic description and we are saving it in a package. Now what you need to do, you have to right-click data model, and you have to create something like from DDIC structure. So provide entity type equal to EMP. You can provide DDIC structure equal to something like Z user info and choose or select checkbox to create entity set also. So automatically entity set becomes EMP set. Entity type is EMP, so automatically entity set becomes EMP set. Please remember that. After creating, you can also observe that. So we are providing both those options here, and I'm just selecting next button. And here I'm trying to select some of the fields from that Z user infrastructure. I'm selecting some of the fields from Z user infrastructure here. You can select the required fields: user ID, first name, last name, email ID, phone, country, salary. So you can use some required fields. You can choose the required fields from DDIC structure, and you can click on next button. And when you're creating entity type, we make one of the field as a key field. While creating entity type, one of the field generally becomes a key field. So if required, you can use multiple key fields also. But you take a key field according to the database table structure. You try to take a key field according to database table key fields. So that is general methodology we follow. I'm selecting, for example, user ID as a key field, then you can click on finish. So you will get all these things. So you can see now under entity type, we got user ID, first name, last name, email ID, phone, country, salary, etc. We are able to get all these things. And you can see this is our EMP. EMP is our entity type. But you can see EMP set is our entity set. EMP set becomes our entity set. EMP becomes entity type. Don't worry about other options now. At right time, I'll introduce the right option. So as of now, this is a very basic procedure to create entity type and entity set. So click on next here, choose required fields from DDIC structure, and select one of the field as key field. So in our case, for example, I've selected user ID as a key field. Then click on continue. So that is a very basic procedure for creating entity type and entity set. That's a procedure for creating entity type and entity set. Every day we are going to use it. Now, after doing this, you can see there is an option. You can save it here. You can save it, and you can see somewhere here there is a option like, you can see there is an option like a green something like red color icon, and that is for generating your runtime objects. That is for generating runtime objects here. So it will create some classes which are required for developer, and it also creates some classes required for framework. It creates some classes for framework purpose, and it creates some classes for developer. I think some people are facing audio problem. Just 1 second. Shafi logged in with another browser. Then who else? Ashok Kumar. Try with another browser. Ashok Kumar, try with another browser, okay, so that you can overcome audio problem. Yeah. So this is a general procedure for creating entity type, entity set. Now, how to create runtime objects? So let us understand what are runtime artifacts here. So runtime artifacts are generally known as classes. Runtime artifacts are generally known as runtime classes here. So the various runtime artifacts are generated for executing, for implementing the service, for implementing and executing the service. The various runtime artifacts are generated for implementing the service and also for executing the service. For implementing the service as well as for executing the service, runtime artifacts will play a vital role. But under this category, there are 6 types of options under runtime artifacts folder. So one is underscore MPC, that is nothing but a model provider class. Underscore MPC, that is one of the runtime artifact, that is nothing but model provider class. And similarly, second one, underscore MPC underscore extension. Underscore MPC underscore extension. So this is another runtime artifact, that is model provider extension class. And third one, underscore DPC, that is data provider class. That is data provider class. And fourth one, underscore DPC underscore EXT. Underscore DPC one second. Shafi, log in with a different browser to overcome audio problem. I think you are, yeah, try that. So DPC extension is nothing but a data provider extension class. And that is also part of runtime artifact folder. And there is underscore MDL, that is model, registered model. We call it as registered model. And underscore SRV, technically we call it as registered service. Registered service. So all these together, all these 6 options together, we call it as runtime artifacts. All these 6 options together, we technically call it as runtime artifacts. Please notice that. So first 1 to 6, all these 6 options, technically we consider it as runtime artifacts. So you can see here, if I click on just a round color icon, if I click on round color icon, you can see it is automatically generating some runtime artifacts like MPC extension, MPC, DPC extension, DPC, and model, and then service. So when you create all these things, there will be one standard table which maintains all these classes or all these runtime options. I'll give that class name later, don't worry. But so what I mean to say is all these together, all the 6 options, whatever you see in this screen, they're called as runtime artifacts. And these things will play a vital role. So what you need to do, just you need to select this icon, then automatically you'll get all these options. Just you can click on continue. And you can save it in package in real time. So now you can see successfully we have created all these 6 options. They are nothing but part of runtime artifacts here. You can see them. You'll get all those options. So when you double click now, you'll get all those options here. Now I can say, now we need to understand one by one, and the main focus must be on MPC and DPC extension. So as far as OData services are concerned, for developer point of view, MPC class and DPC extension class, these are very important. So other things are used by framework for executing our functionalities. But we try to write our functionalities by using these 2 classes, DPC extension and MPC class. So now, first of all, let us understand what exactly MPC class contains. Don't forget, we have created one entity type here. Don't forget, we have created one entity type which contains all the fields. And don't forget, we have just created one entity set. So according to the entity type fields, according to the entity set, all those options will be registered internally in MPC class. So based on the fields, based on the data type, based on the entity type name, entity set name. So whatever we use in entity type, entity set, those options will be registered in MPC class by the framework automatically when you generate these artifacts. So you can see now, first let me go to MPC class here. Don't worry too much and don't think about other options. Concentrate on what I'm explaining because they are going to play a vital role. They are the pillars. So as of now, you can see MPC. Let me double click here. When you double click MPC class, you can see something like one method is generated here. One method is generated that is nothing but define EMP. So define EMP is a method that is generated automatically when you generate runtime artifact. And the code inside this method is also auto-generated, but let us see what exactly is implemented here. Just let me double click that define EMP. So under this EMP class, just you need to know but we are not going to change this code. You need to know what it contains. So if you closely observe here, there is one field as user ID with some key field and data type is idiom string. Length is 5. And you can see first name is a field registered here with length 10. And last name is another field registered with string data type length 10. And email ID is another field with string data type length 15. Phone number string with length 10. And you can see country field, and you can see salary field with int 32 data type. And not only that, you can see here our dictionary structure is also registered here as Z user info. Our dictionary structure is also registered here as Z user info. And you can see our entity set name is also registered inside this method, that is emp set. And what is our entity type? That is also registered here. Entity type name equal to emp. Entity type name equal to emp. So what I mean to say is this method define emp is auto-generated, and inside that method some metadata is also registered here. Some metadata is also registered here. So what I mean to say is what model provider class contains. So that is the main point at present. So I can say a model provider class contains just metadata. It contains metadata of our service. Contains metadata of our service. But technical, what do you mean by metadata? So metadata means the name of entity type that is registered in this MPC class. Name of entity type that comes under metadata. And name of our entity set, so that also comes under metadata. And each field of entity type comes under metadata that is registered in MPC class. And the data type of each field also comes under metadata that is registered in MPC class. And then the length of each field of entity type is also registered in MPC class as metadata. And DDIC structure. DDIC structure used for creating entity type. So that also comes under metadata here. Name of DDIC structure which is used in this service, so that comes under metadata and it is registered in MPC class. So please notice that. So this is what mainly metadata contains, and this is maintained inside MPC class. Now you can see here, not only this, you can see there are two more options which are very important for us. If you go to MPC type section, If you go to MPC type section, you can see table structure EMP, table type EMP. So that is also auto-generated according to the fields of our service. Table structure EMP, table type EMP. So this is also created automatically in MPC class. One is table structure, another is table type. So that also comes under metadata here. Table structure and table type. So that also is registered as metadata inside model provider class. So, but in what way? In what way we can use this MPC class? That is important for us. As a developer, how to utilize this model provider class? That is important for us. So, first of all, we are going to utilize this MPC class, but we don't write the code inside MPC class because you can see here under define EMP method, SAP is clearly saying that never modify this class. SAP is saying that never modify this class. So under MPC class, developer has nothing to do here. So this class is utilized by our service for runtime execution. This class is utilized by framework to execute the service or a project. But as a developer, we don't touch this particular class to implement the code. Because you can see that comment here, never modify this class. So what I mean to say is, this MPC class is used by framework to execute our service. This MPC class is used by framework in order to execute our service. I mean to say, this MPC class should not be modified by developer. It is used by the framework, but you should not MPC class should not be modified by developer. Please notice that it is used by framework for executing the service. Now, but in what way we can utilize this metadata? That is important. We don't write the code in that MPC, but we use that MPC class. We don't directly write the code in MPC class, but we utilize that MPC class for declarations. So declarations in OData ABAP services. So let me explain those declarations here. Say for example, I want to declare one work area. If you want to declare work area in OData service, then you can make use of a data statement. For work area, you can use data statement. And you can use, for example, WA type ref2, or you can use type. You have to use something like Z model provider class, Z model provider class, and you can use equals arrow mark, and you can refer to table structure underscore EMP. So our work area will be created by using this type of syntax. Model provider class with table structure. You can utilize it like that. Now, if I want to declare an internal table, then what we do is we try to use a data statement. We use a data statement, for example, iTab, and you can use type Z model provider class. This is Z model provider class, and you can use equals arrow mark. TT you have to use TT underscore EMP. So TS is table structure of our MPC class, and TT is nothing but table type here. Please notice that. So that means as a developer, we are going to utilize MPC class for declaring work area, for declaring internal table, for declaring required fields. You can utilize model provider class only for declarations with table structure, table type like this. Say for example, I want to declare a single field. For example, I want to declare a single field. I want to declare a single field, then you can use data statement, and you can use, for example, salary, then you can use type, Z model provider class equals arrow mark, table structure EMP hyphen, you can use salary field. That is how you can utilize. Table structure, MPC class, table structure hyphen hyphen salary. Model provider class, table structure hyphen salary. So that is how you can refer to an individual fields also. Similarly, for example, I want to use first name, F name, then you can use type. You can use Z model provider class equals arrow mark, then you can use table structure EMP hyphen, for example, first name. You can declare like this. So that is how we can utilize our MPC class. The main purpose of this is to make you understand how can we use our MPC class. We don't write code inside MPC, but we try to use MPC outside that MPC class by using these different declarations. So this is how we can utilize a model provider class for single field, internal table, work area, etc. So please notice that. And now you can see, if you create 3 entity types, then automatically 3 table structures and 3 table types will be generated in MPC class. Don't forget that. For example, if you create 3 entity types, then automatically 3 table structures and 3 table types will be available in MPC class. Let me repeat. If I create 3 entity types, then automatically 3 table structures and 3 table types will be available in MPC class when you generate runtime artifacts. Now, notice this point, and this is a very simple and important point. Three table types, 3 table structures are generated in MPC class. You have to notice this point. And not only that, you can see here, let me go back. I'm not writing anything as of now, just I'm trying to give some overview. You can see here, there is a DPC extension class here. There is one more class that is a DPC extension class. You can see that. DPC extension, let me double click that. So you can see there are several methods generated here. There are several methods generated here. But if you closely observe under DPC extension, the last 5 methods, we call it as CRUD methods. So let us understand this. How data provider extension class is generated or how it is formed, let us understand that now. So you can see here under data provider extension class, I can say last 5 methods are generated based on the entity set name. You can see here, if you closely observe, EMP set is our entity set. EMP set is our entity set, and based on the entity set, you can see our CRUD methods are generated here. Our CRUD methods are generated like create entity, delete entity, get entity set, update entity. So these are all CRUD methods. So if you create another entity set, then there will be 5 more CRUD methods for that entity set. If you create third entity set, then there will be 5 more separate CRUD methods for that entity set. So what I mean to say is, for every entity set, 5 CRUD methods will be generated. So please notice that. So what I mean to say is, you can see here the first method that comes under, this comes under, okay, let me write somewhere here. Several methods are auto-generated in data provider extension class. Several methods are auto-generated in data provider extension class. And I can say, moreover, each entity set contains 5 CRUD methods in data provider extension class. There will be several methods, but apart from those several methods, there will be 5 CRUD methods also in data provider extension class. Each entity set contains 5 CRUD methods in data provider extension class. So that means entity set underscore create entity, that is a method generated here. Entity set underscore create entity, so that method gets auto-generated. But this comes under C. In CRUD operations, we call it as C. CRUD, C means create. And similarly, based on the entity set, something like get entity method is also auto-generated. Get entity method is also auto-generated, and getting the data, that we call it as read operation. Getting the data, we call it as read operation. Please notice that. R means read. That is to fetch the data. Similarly, based on entity set, get entity set method is auto-generated. Based on entity set, get entity set method is auto-generated. And I can say this also is part of a read operation. Getting the data, that comes under read operation here. So it is for fetching the data. And based on entity set, update entity is a method auto-generated in data provider extension class. Update entity method is auto-generated in extension class, and this comes under U. In CRUD operation, we call it as U, that is for update. That is for update functionality. And similarly, there will be one more method that is based on entity set. Based on entity set, one more method will be generated, that is delete entity. And this also comes under CRUD operations, that is D, that is for deleting a record, something like that. So what I mean to say is, every entity set you create in OData service contains 5 methods. They are nothing but CRUD methods. And I mean to say, for example, if we create 3 entity sets, then automatically I can say 3 into 5 CRUD methods. That is equal to 15 methods will be available in data provider extension class. Let me repeat. If we create 3 entity sets, then automatically DPC extension class generates 3 into 5 CRUD methods. So overall, there will be 15 methods. So please notice that. Apart from these methods, there will be some common methods also. Okay, so we'll discuss in detail, don't worry. But at present, this is a point which is important. And let me tell you, as a developer, we implement almost all operations or functionalities inside data provider extension class. Data provider extension class. As a developer, let me repeat, very important. As a developer, we implement almost all operations or functionalities. We implement almost all functionalities. In the bracket, I can say database functionalities inside data provider extension class. That is the use of this class. So developer point of view, this class is going to play a vital role because we write our coding we write our database functionalities inside DPC extension class. So this is a developer related class. You need to understand how exactly data provider extension class is created. You need to know how data provider extension class is generated. So as of now, I have discussed what exactly data provider class contains. What are the main options in data provider class? Data provider extension class, I gave some information here. But how exactly SAP will generate this data provider extension class? So that you need to understand now. Let us go with a diagram. So what SAP will do is when you click on this red color icon, what happens is, first of all, one data provider class is created with some methods like some create or delete or whatever methods, delete MD. I'm just explaining the behavior of the formation of extension class. Delete MD, something like change MD, some methods will be auto-generated. Inside data provider extension class, it looks like this. This is in data provider class, sorry. First, this class will be created, data provider class, and it may contain some standard methods. And not only that, internally, it also generates some interfaces here. It also generates some interfaces like interface I1. And it contains some methods like create MD, interface is generated like I1, and it also contains some methods like create MD and something like update MD, whatever. Display MD or whatever, some methods. And similarly, there can be multiple interfaces like interface I2, and it can contain some methods like read MD or display MD or select MD, whatever. Just to understand the behavior, I'm writing some sample methods here. So an interface can have like this. So this is the internal structure I'm trying to tell you. You need not create all these things, but these things are generated by SAP in the manner which I'm going to explain in this diagram. So this is the internal part. So after creating one data provider class and multiple interfaces, it will try to generate something like one data provider extension class. It will create data provider extension class. And what I can say is this class will try to gather the methods of data provider class. Internally it will do. You need not do these things. Internally framework will do all these options. Framework is responsible to do all these things. So I can say framework will be responsible to do all these things. You need not worry, but it's better to know what is happening in the background. So it will try to take, or it will try to gather DPC class methods into DPC extension class, and it will try to gather those methods and it will place it in DPC extension like create MD, delete MD, and something like change MD. So these are the three methods it is trying to gather from data provider class into data provider extension class. DPC class methods are gathered and placed inside DPC extension class. Not only that, I can say the methods of interface I1. The methods of interface I1, they are also gathered and it will be placed inside data provider extension class. That means now you will get the methods with the name interface name I1, then tilde symbol and method name create MD. You'll get like this. Interface methods will participate in extension class by using interface name, tilde symbol, and method name. Interface methods will participate in extension class by using interface name, then tilde symbol, then method name. Similarly, interface I1 contains one more method, for example, update MD. It also will participate like this. And similarly, interface I1 contains a method like display MD. So it will participate here. Now, not only that, it can take methods from a DPC extension class, will gather the methods from several multiple interfaces like this. It will gather methods from multiple interfaces. So for example, you can see interface 2, I2, interface I2, tilde symbol, method name, read MD. And interface I2, then tilde symbol, then method name, display MD, something like that. And interface I2, then tilde symbol, select MD. You get methods like this. So what I mean to say is extension class will gather methods from DPC class. It will gather methods from one or many interfaces. It will gather methods from DPC class. It will gather methods from one or many interfaces. And not only that, as a developer, what you can do is you can add your own methods if required. You can add your own methods if required. For example, something like some custom method M1. Some method, something like X method 1. Similarly, Y method 2. Something like Z method, something like 3. So that means you can add your own methods if necessary inside extension class. That is the point. As a developer, whenever required, you can also add your own custom methods here. Something like method 1, 3, etc. So that means overall I can say DPC class contains methods of a DPC extension class contains methods of DPC class. DPC extension class contains methods of DPC class itself. And not only that, it can contain methods of multiple interfaces also. It can contain methods of multiple interfaces also. Method of interface I1. It can contain like this. Not only that, it can contain methods of interface I2 or I3, whatever. And not only that, it also can contain a custom methods or new methods. If you want, you can add your own methods. So this is how our data provider extension class is generated when you click on that red color icon. When you click on red color icon, so all these things will internally happen and it will provide data provider extension class for us. So now as a developer, you need to know that DPC extension class is the important class because it contains all the methods whatever we require now. Whatever is required for our service, everything will be available in data provider extension class. So that's the reason why DPC extension class is a developer related class. So let me give a simple note. First, let me save this so that I can send it to you. That is how the formation of DPC extension class will take place. And new methods if required for developer. So very important note, as a developer, almost all our required functionalities are implemented in DPC extension class. So please notice that point. They are implemented in DPC extension class. So that is how it looks like. Okay. So this diagram is important. What happens internally when you click on that red color icon? So these things will happen. Whatever I wrote in the diagram, so those things will internally happen when you click on that red color icon. So the only thing is you need to know how to utilize these methods, how to write our own coding, and how to develop the front-end screens in UI5 and Fiori. So that we are going to do it in the coming classes, don't worry. But this diagram is the most important diagram. I'll stop for today and tomorrow further. If you have any doubts, you can ask me.